newer thing here, and today we're here to watch D Marble attempt to educate us globe believers on how physics works.
One of the comments that I always get in these flat earth videos that I'll upload, typically the ones I'll do about the movements of the celestial bodies or gravity, one of the responses I always get from these globe believers, the more triggered ones, is you don't understand physics.
And you haven't ever thought that they might possibly be right and that you're wrong?
And my response is always pretty much the same. I'm like, oh look, another physics expert. Well, here, how about this, genius? Go ahead and explain the physics of liquids or water.
Water is a liquid, and liquids flow and do not have a fixed shape. The forces between liquid particles are weaker than the forces between solid particles. This means that liquid particles are further apart and can move more easily. The particles will flow until they find equilibrium, either by equaling out all the forces acting upon it, or just simply contained within a container. Another important physical property characterizing the flow of liquids is viscosity. But I know that you have no care, and words like that will flow right over your head.
Now, do they ever do it? No. For some reason or another, globe believers like to tiptoe around that particular aspect of physics. So,
this is demonstrably untrue. It's not that our side won't discuss the physics of water. No, it's that your side, the flat earthers, are so indoctrinated that y'all can't tell the difference between the words flat and level.
let's do a quick check on understanding, a real simple rudimentary exercise, and then we're going to look at physics real quick. How about that?
Wait, is that a test? Hey, I passed one of those back in middle school. Come on, Flurfer, show me what you got.
Now, what do you see here? A globe. B, a bowling ball. C, a spherical balloon.
A globe.
A globe.
Yay! I like this test. I may actually be able to pass it.
Moving on. Now, what is the most prevalent surface color on this globe? A, white. B, green. Or C, blue?
C, blue.
Blue. Very good.
Yes, I'm 2 for 2. And look, guys, I know what you're thinking, and I swear I'm not looking ahead and checking out the answers beforehand.
What does the blue on the globe represent? A, land masses. B, water. C, lava.
M! Is he right?
B, water. You would be correct if you guessed B.
Damn, there goes my last chance at an A for the last 5 years.
Under what state of matter is water classified? A, a solid. B, gas. Or C, a liquid?
C, a liquid.
And if you chose C, you are correct.
Hey, 3 out of 4. C's get degrees. Am I right?
Now, let's take a look at the conclusion here. Most of the Earth's surface is covered by liquid. That's what we just established by answering those questions.
And when you combine that with one of the main properties of a liquid, that it conforms to either a container or it seeks equilibrium of the forces, you can come to the conclusion that the Earth must have some kind of force acting on this liquid to keep it at bay and hold it in equilibrium at this kind of scale.
Still with me? Good. Now, let's take a quick look at a short video outlining the physics of liquid.
Liquids seek their own level.
Okay, so to go along with that, here's an example. Here's a cross-section side profile of the Panama Canal.
Oh, jeez. You know what the sad part is? I already know where you're going to try to go with this.
Now, this side profile here shows that, in correlation to what we just saw as the physics of water, that the surface of water is always flat. That water, liquids, seek to find their own level.
Yeah, and there it is. D. Marble, confusing the words flat and level, thinking that they mean the same thing. Just like we've seen over and over and over and over.
Now, you in your own personal experience have never seen water do anything on the surface other than represent a level surface.
I love how he knows my experiences and all of that, because I actually have seen the curvature of the Earth with my own two eyes personally without any equipment involved. And that's not even counting the countless amount of experiments and countless observations of the Earth's curvature that has been done by not only this community, but throughout all of time altogether.
As if a perfect mirror. Now, if the surface of water were bulging, such an effect wouldn't be possible. This whole mirror thing that we have going on right here, that's not possible if the surface is curving.
I love how he says that this is a perfect mirror. Like, there's nothing wrong with this mirror. It's absolutely perfect. And it's only possible on a completely 100% flat surface. And not that this could just be a really good mirror on a surface that curves a minuscule amount over a tiny distance.
But then this is where people would make excuses saying that this particular body of water is too small and that there's not enough space to see the curvature.
That's not an excuse. That's a fact. And you know that it wouldn't be large enough to see the curve. So you putting this in this video just shows how dishonest you are.
So let's take into consideration what you're seeing here. This is the world's biggest mirror. It's the salt flats in Uyuni, Bolivia. This place is 100 miles across and about 80 miles wide. And after it rains, there's about an inch or two of water and it becomes a perfect mirror, as you can see here.
Again, we have the words perfect mirror. Not that it can't possibly be a really good mirror with a slight curve over a relatively small distance. No, it has to be a perfect mirror. And I'd like to point out, what's up with those mountaintops in the background, and why can't I see the bottom of them?
That doesn't happen on a globe. That's entirely too much missing curvature. This is one of my originals from a while back, and this is just to get you thinking about this stuff, the simplicity of where we are.
Every time I hear a flat earther talk about how simple the flat earth is, it just reminds me of this comic. And sorry, bud, but the simple answer is not always the best one or the correct one.
Whether it's water in a glass, whether it's in a pond, a puddle, in a lake, or on the ocean, the surface is always flat and level. You need to take into consideration the fact that bodies of water only appear to curve in pictures that you will never be able to take for yourself. And that's the pictures of the entire globe. Chances are you're never going to go to space and be able to snap that picture. Neither am I. But what we know in our reality is that the surface of water is always level. So, I'll admit it that both of these models have their own flaws.
2 questions. 1, what is the flaw in the heliocentric model? And 2, what are the flaws that you see in the flat earth model?
But you gotta ask yourself, which one of these matches your experience in reality?
Seeing that I have personally seen the curvature of the earth, how I've never witnessed the sun nor the moon change size throughout the night, how I've seen the tides work and witnessed the stars move across the sky, also how I observed an equatorial mount work and move with the stars across the sky without any trouble, I'm going to go with the globe earth model. And not just because of all that evidence, but because of 1,000 other pieces of evidence too. Well, that's it for me tonight. Thank you guys for watching the video. I enjoyed making it. And be on the lookout for some more content in the future. If you guys want, follow me on Twitter at Blue Earth Thing. I'm also on Instagram now, also at Blue Earth Thing. And if you want, please like and subscribe the video. Make a comment, whether you are a globe earther or a flat earther. I enjoy every single comment that I get. Thank you guys for watching, and Blue Earth Thing out.